Hi everyone, this is the Phala native Phat contract demo. My name is Joshua, #warlock on Twitter. So let's get started. So my use case was I wanted to create a ghost auction for my RMRK NFT collection, and I wanted to do it in a confidential way to ensure that each bidder would be guaranteed to get their bid in through Phala's Phat contract. So here I'm going to show you one of my collections, 47 locks, just to get you to understand like the RMRK 1.0 NFT standard where you can upload an NFT and post it here on their marketplace called Singular. Now I'm going to check out one of these that I want to auction. So for this instance I'll pick Punk Bubblegum, and here you can see here's Punk Bubblegum. There's a little RMRK logo on the back. But as you can see in here, like your options, you can set a price that someone can buy, you can gift it, you can clone it, you can destroy it. But you can't really do much else. For instance, you can't auction your NFT. So take a dive into like the details. You can see that you can set a description here, go through the history as well, which will show you when I minted it and listed it for sale. You can also send an emote to the NFT, so you can react to this. Pretty cool. Send whichever emote, which will come in handy later on down the road as the RMRK standard expands. But here's the NFT, and this is just the basics of what I was after when it comes to being able to auction off my NFT as using the Phala native Phat contracts. So this ID here is going to come in handy later as I go further into the implementation. So you go to the Phala.network, English version for me. Go into the wiki and check out the developer guide. Here you'll get to the Phala blockchain in detail, where we will go over the Phala blockchain high-level architecture. So here we have the Phala Node, which is the substrate-based blockchain node, the pRuntime, which is the off-chain trusted execution environment, and then the pherry, which is the bridge relayer that will bridge that communication between the Phala blockchain and the trusted execution environment of the off-chain worker. So next we're gonna jump into the next section, run into local development network, which will get us to show our example of the ghost auction that I've developed through the Phala native Phat contracts. So moving forward here, as you can see, we are in the run a local development network. They have a high-level overview of the Phala Node, pRuntime, and pherry. Here we have the different environments you could run in, which is Ubuntu Linux, Linux Fedora, Windows Sub Linux, and then the Mac OS section, which will recommend you to use like AWS to run a Ubuntu Linux VM to be able to execute this. So here, as you can see, we roll down a bunch of installation steps that you have to take, but I'm going to go straight into the building of the Phala blockchain node. So here you can see I have my different repositories pulled down. So I'm just going to go here and build the core blockchain with the cargo build -- release within the Phala blockchain directory. So go change directory here. Yep. And for some of you, it'll take you up to like 20 to 40 minutes to build this. I had recently just built it, so it's going to take me about 2 minutes, but for longevity's sake, I'm just going to skip through. So here I have my blockchain node built now, and I'm gonna build my off-chain pRuntime trusted execution enclave. So we're gonna go into the standalone pRuntime, and we're gonna set it to SW because here we're doing a virtualization since I don't have an Intel CPU, I have an AMD. So here, and this will take a little while to do. Here we're built now. So the next steps would be deploying our blockchain node and our pRuntime and our pherry so that we can have our pherry relayer communicate between our Phala node and our pRuntime. And in our wiki we have a little example and a little GIF to show you what it should look like. So here I'm going to copy and run a temporary dev node so that the database will be cleared once we stop the blockchain node, so it isn't cached. And go into target. Release Phala Node --dev --temp. And then I'm going to go over to my next tab and then deploy the pRuntime. So here you can see we have some blocks being generated. So here we're going to need to go back into the Phala Node blockchain folder and go into standalone pRuntime bin, and then execute app-c0. /app-c0. There we are. As you can see, the rocket has launched from port 8000. Next, we're gonna deploy the pherry. Now we're deployed. So next steps will be deploying our front end through the JS-SDK repo that hosts the front end code. So if we scroll down in the wiki, get down here, and this will also give you an explanation on the TCP ports.
And note that
just to make sure that
the
they're
Phala
not
Node will be
occupied
using
by the
9944 and 30333, along with the pRuntime using 8000. The pherry node doesn't listen on any ports, but connects to the Phala Node's WebSocket port, which is the 9944 that you see up there. So we're going to deploy the front end and move to the next tab. Here, move into the JS-SDK folder structure that hosts our project. There it is. And in the example, you'll see it goes into packages / example. For your development and my development that I did, I created a new folder structure that labels my Ghost Auction. So in this example, I'm showing you that based on my development, I'm able to change into my Ghost Auction to deploy my
native Phat contract front end here, and I'm going to show off the .env properties here so that you can see for future, and then copy that for my local deployment there, and then do a yarn install and then a yarn dev to deploy it. Yarn dev, we should be deployed now. So there's the local host at port 3000 that we're going to access to interact with our native Phat contract. So in the wiki you can see that we use some test wallets. So we're going to use Alice, Bob, and Charlie. I already have Alice and Bob imported in, but I'm going to show you how to do this in the terminal to get the secret seed phrase so you can import those wallets into your browser for polkadot.js. I'll need to go into the Phala blockchain instead, so I need to erase this real quick. And then execute the command, and as you can see I'll have all of Alice's information here. Do one for Bob and then one for Charlie. There we are. So I'm going to take that secret seed right there at the top. This is for Alice, but I'm going to use Charlie's because I want to show y'all an example and be able to have multiple people participate in the Ghost auction for the NFT that I'm auctioning. So here you go into polkadot.js after you copy Charlie's seed here. Go to your polkadot.js, add import account from pre-existing seeds, and then paste it here instead of the mnemonic word phrase. There we are. Set it to allow use on any chain for now. Next, give him a name, Charlie, and a simple password, since it's just a test. Nice. So now we got Charlie. And since we have that, now we can interact with our native Phat contract since everything's deployed now. So we'll go to the local host, port 3000 here, and we'll use Alice as the NFT auctioneer and configure a ghost auction. So click here. We're going to sign the contract. And signing the contract is part of the steps to be able to interact with it, so you'll know who's interacting with it and have permissions configured here. I'm going to also set up my Telegram channel bot so that I can get my chat ID here. So up here's my chat ID of this Telegram group for 47 locks, people that want to participate in the auction. Post that here in the chat ID. Get my bot token and post it here. It's just a bot that I have. If you want to mess with it, you can. I hope you don't. But that's the bot token there. Sending that in. Now this is going to change the contract state, and only Alice can do that now because she is the owner of the contract. So the command sent, we have our bot setup, our Telegram bot setup. Going to erase this stuff here and query the bot token, or not the bot token, but the chat ID, just to ensure that it's configured correctly. So there we are. It's the same as what we configured it as by executing the query command. So now we're going to go back to that NFT remark collection that I created to get Punk Bubblegum's NFT ID, and then start the auction. So we're just going to start it at 1 KSM as the reserve price. So from there it'll go up by 1, so the next bid price will be 2 KSM. So here's our ID. Copy that. The cool thing is we'll be interacting through the HTTP endpoint set up by Remarks 1.0 team, and we'll be able to get all the basic metadata from that HTTP request so that we can list all the contents of this auction once we start it. So now we're submitting a new Ghost auction, and we should get an update from our Telegram bot to the 47 Locks Telegram group. So our command sent, so we should get an update from Telegram, and we can check on that to see if the new Ghost auction is successfully created. Check it out. Here we are. We got a new Ghost auction alert. Punk Bubblegum with the NFT ID, the metadata to the IPFS location where the NFT data is stored, the URL, and the starting bid price, which is 1. And in this point, it's 1 KSM. And we can look down here. There's the NFT ID from the query current NFT ID button. And now we're gonna have some of our users, first Bobby, to do an auto bid on the Punk Bubblegum NFT. And this here right now is just a hard auto bid increase, so it'll be 2 for the next bid. So we have Punk Bubblegum and the current NFT price. We're gonna query that next. That's 1. So let's send a new auto bid. Sign the transaction, and we should get an update from the Telegram group that there is a new top bid of 2 KSM, but it will not share the contents of who is actually bidding on the NFT, just to protect the bidder's privacy. And here we are with the NFT ID has a new top bid of 2 KSM. So now that's the new top bid, and that's posted directly into the Telegram group. So now see here, we have the current NFT price now is posting as 2. So now Charlie's gonna come in here because he was in the 47 Locks group and he thought he would like to have a go at participating in this Ghost auction. So comes in here, he just checks to see which NFT ID is up for auction, which is Punk Bubblegum, and queries the current price. He thinks 1 plus 1 KSM would be 3 KSM now, so he's gonna just go ahead and send that auto bid. and command is sent. So we should be getting an update in the Telegram group that we have a new bid of 3 KSM, and you can see that here down here the new top bid is now 3 KSM. And Bobby doesn't like that, so Bobby's gonna come back in here, sign the certificate, sign a message, and just ensure that it's Punk Bubblegum that's still being auctioned. Query the NFT price, which is 3 now. So he's willing to put 4 KSM up. He's gonna send the auto bid, sign the transaction, and just for the sake of just ensuring that we can see the Telegram group update live, I'm gonna go a little bit earlier. Once the command is sent, there we go, we're gonna move over and just see the live update. Boom. 4 KSM is now the new top bid. Now just for fun, I just want Charlie to win. So I'm gonna go in here, get Charlie's account, sign real quick, query the NFT price, which is 4, the ID, send an auto bid, and now we're gonna have a top bid of 5 KSM. And from there, let's just say it took the amount of allocated time that Alice wanted the auction to run for. So after this bid executes, we're going to simulate the settling of an auction through Alice's account. So here we are, there's 5 KSM. All right, so we're gonna switch over to Alice. Alice signs the certificate. She's in here now, and she is going to settle auction. Click. And when she settles the auction, it'll state the NFT ID and the winner public key to the Telegram group to signal the winner of the NFT Ghost Auction. Command sent. And there's logic within the native Phat contract to ensure that this auction can't be run again, but here it is. Auction is closed and has been sold for 5 KSM to account ID there. The SS58, I believe, format public key. We're gonna validate that here just to show you. There it is from Charlie, the 5FL. Yeah, there you are. Check it, and you can validate there. So this is just a small example of what you can do with the native Phat contract development. And for anybody that has any questions, please reach out to me you can reach out on Twitter or on Discord. Most of my usernames are #warlock, so just reach out to me and I can give you more information and even help you with some of your development adventures if you want to expand on this, or say you want your own project where you're using these HTTP requests from the off-chain worker, so you can develop some really cool projects, because there are plenty of projects out there that were in the hackathon that were very impressive that I think would be very interesting to have more eyes on. Thank you for watching this video, and I hope you all have a great day. Signing out. Thank you.